In this session, we're going to introduce application of frequency analysis for signals. And the application is sampling signals in the time domain. So we're going to start from why do we have to sample continuous time signal? Sampling signal in the continuous time can be done this way. This is a continuous time signal, and we want to record only the signal value at a certain time. So what we can do is we only sample, for example, when time equal to capital T in here, get that value, and then move to the next sampling point, T equal to 2 times capital T, to get that value at that moment, and so on and so forth. Instead of getting the entire curve, we can get only these discrete time points. So mathematically, we can use this equation to describe the relationship between the continuous time signal and its discrete time version. There are some advantages to convert signals from continuous time domain to the discrete time domain. So what we can do is we can process the signal in the discrete time domain, and then after we get the output, we can reconstruct it, convert it back to the continuous time domain. And this type of system can provide us a lot of advantages. For example, it is more convenient for us to store, transfer, and process signals. Here are some examples. Based on analog techniques, we can use tapes, cassettes, or films to help us store videos, soundtracks, and photos. But we can do this also using digital techniques, and they actually have a lot of advantage. For example, they can have larger capacity. They can have a better stability. Here is one example. This photo, after a long time, going to be having a lot of stains for whatever reason. But for digital photos, they do not change. The quality won't change a long time. Also, the analog signals, they often prone to noise. Well, if you sample it in the time domain and then quantize the amplitude, and then we can encode them using either 1 or 0. These two different levels, and they will robust to noise, given that the noise is not too large. And the digital signal is also robust to noise. Here we're going to have 2 soundtracks.
中央人民广播电台新闻综合频率，中国之声。
A transmitted signal with analog techniques. Well, this will be the digitized signal.
中央人民广播电台新闻综合频率，中国之声。
We can hear clearly that the digital version has a much better audio quality. This is a comparison for analog TV and digital TV. It's also apparent that the digital version is much better. For signal processing, here's one example for speech signal encryption. After digitization, the digital speech signal can be encrypted very easily. Here is the flow chart of the whole process.
人际交往重在沟通，国际交往尤其需要沟通。
Then, after signal encryption, here will be the results. And you won't be able to hear anything in here because it is already encryption using digital techniques. With digital watermarking, we can also try to embed some trademarks into the original digital image. So this is already embed the watermarks in here, but you won't be able to tell difference between these two images. That will give us some advantage for IP protection. Also, using the digital technique, we can also process music signals very easily. Here we can use these 3 cascaded signal delay unit to do music reverberation. Here is one way we can use digital signal processing technique to help us to do phase localization, mirroring, matching, and retrieval. That can help us identify different persons using digital techniques.